So this is section 1.6 on inverse functions. If you want to take a minute to pause the video and write down anything you know about inverse functions, so it could be from Algebra 2, you can take a minute and do that. And then when you're ready, we'll move on. So first, let's think about the definition of an inverse function. So that is a function which the inputs switch with the outputs. So inputs are x values and outputs are y values. So if you think of that word inverse, it's like the opposite, maybe switching, something switching. So we're switching the x and the y. And we write this, so if we're finding the inverse of f or f of x, we write that as f to the negative 1 of x. So normally we have f of x. We now have this little negative 1. We don't read that as a negative 1. We read it as f inverse of x. So f inverse of x. So now moving on, I can show you a couple examples of functions. So let's say we have this function right here, x and f of x. Keep in mind, f of x is another way we can say y. So this is my x row, this is my y row. So 1, 2, 3, 4, 5, 6. This is a numerical way of representing data. So if I want to find the inverse of a numerical representation, so that could be a table, it could be coordinate points, any way of writing it like that. So x and y values, we switch x and y. So the inverse, it wouldn't be 1, 2, 3 as the x, it's going to be 1, 2, 3 as the y. So instead of writing f of x here, I'm going to put f inverse of x, still means y. And now I write 1, 2, 3 as my y values and 4, 5, 6 as my x. So you're literally switching the x and the y. So how do we verify that two functions are inverses? So to verify something, we want to prove it. We want to show that it is true or that these two functions are in fact inverses. So to do that, we need to use the composition of functions, which we learned in the last chapter. So we want to show that f of f inverse of x, so that means plugging in f inverse in the f function. We want to show that that equals x. We also want to show that f inverse, whatever that might be, of f of x equals x. So let's say we have a function f and a function g. We want to show that it equals x, and then g of f of x also equals x. So we can think of this like when we did examples like this, f of g of x and g of f of x. So we would want to show that both of these functions, no matter what their names are, equal x. And that means that the two functions are inverses. So let's do this example down here. Show that f of x and g of x are inverses algebraically. So we're going to use this method. So first we find f of g of x. So what that means is we take the f function and we plug in whatever g is. In this case, g happens to be x minus 1 over 2. So what that means is we're going to take f, 2x plus 1, because we have an f here. Instead of filling in an x next to the 2, we're going to fill this in. So we're going to replace x with this, 2x minus 1 over 2 plus 1. So instead of writing 2x plus 1, I fill this spot, I replace x with g of x. So now we can put 2 over 1. In order to multiply a fraction times a fraction, we have to multiply across top and bottom. But here we can cancel. We have a 2 on top and a 2 on bottom, so those cancel out. So 1 over 1 times anything is just itself. So we have x minus 1 over 1. So that is just x minus 1. And then we have this plus 1 on the end. Now minus 1 plus 1 cancels, and we get x. So f of g of x equals x. Our first job is done. Now we have to show the opposite way. We need to show that g of f of x also equals x. So g of f of x right here would be g f of x is 2x plus 1. So let's plug that in the g function. So anywhere we see an x, this is what we're going to write. So 2x plus 1 minus 1 all over 2. Now let's start by simplifying this top part of the fraction. Plus 1 minus 1 gives us 0. So we get 2x over 2. These 2's cancel out to be 1 over 1. So we get x. Check. F of g of x equals x, and g of f of x equals x. Therefore, these two functions are inverses. So now I want you to take a minute, try out this example, and then you can pause this video, and then you can play it up again to get the answers. So there are the answers to the U try. F of x minus 4, because that's g of x. When you plug it in, minus plus 4 plus 4 cancels out, you get x. The opposite way, so now we are taking g and plugging in f. G is x minus 4. Plug in x plus 4 for x, minus 4, cancels, we get x. And that is how you would do that example. We're going to skip the part on showing inverses graphically, and now we're going to move on to finding an inverse algebraically. So there are 3 steps. There's actually 4 steps, 3 right here. So first, replace f of x with y, if necessary. So if it already says y equals, you don't need to do this step. The second step is switch x and y in the equation. So both of these steps are literally just rewriting the equation. Here, we're rewriting y instead of f of x, and here we're rewriting an x where we see a y and a y where we see an x. And the last step is we're going to solve for y. Now at the very end, so I'm going to tack this on as a 4th step, we're going to write f inverse of x instead of y in our final answer. And I'll show you what I mean by that. You're literally just going to write this instead of y equals in our final equation. So looking at the first example, we're going to go through and do steps 1 through 4. So our first step would be to replace f of x. We're going to write y instead of f of x. Second step, switch x and y. So x equals 4y plus 1. Third step, solve for y. So that means get y alone on this side of the equation. So start by subtracting 1 on both sides. So this is just using your methods of solving, and then divide by 4. So I like to think of solving an equation like doing the reverse of PEMDAS, or order of operations. And then as our very final step, we are going to write the final answer as f inverse of x. So f inverse of x equals x minus 1 over 4. And there you have it. So to do that in a second example, we can take B. We're going to run through that same process, 1, 2, and 3, and the last step 4. So the first step, replace f of x with y. Second step, switch x and y. And so you don't want to change anything about the equation, you just want to switch those 2 letters. Third step, solve for y. Add 1 on both sides. So we're left with 2y to the third over here. Divide by 2. Make sure you divide everything by 2. Just like over here, I divided everything by 4. We need to keep things equal in our equation. So I get x minus 1 over 2 equals y to the third, or x plus 1 over 2. And now to get rid of a to the third power, we're going to take the cube root. So it looks like a square root, but with a 3. So our final answer, when that cancels out, is going to be f inverse of x. So of writing it as y, f inverse of x equals the cube root of x plus 1 over 2. And notice my cube root goes over the entire fraction. So now I want you guys to try the ones right down here. And then I will show you the answers. So here you can check your answers. For A, f inverse of x equals x minus 12 over 3. And for B, we get, and actually, should have a square root of x minus. So for the second one, f inverse of x, square root of x minus 2 over 3. Last thing, so not all functions have inverses. So in order to tell if there is an existence of an inverse, if a function has one, the function has to be 1-to-1. So what this means is that every input has one output, which is the definition of a function, and every output has one input, which means it has an inverse. So instead of just every x having one y, every y also has one x. And so it must pass not only the vertical line test, but also this horizontal line test. And so if you can kind of guess what we're going to do there is we draw a horizontal line and see if it crosses more than once. So this is a good example of this one right here. When we draw a horizontal line, you can see it clearly only touches one time. So this would have an inverse. This one, you draw the horizontal line, you can clearly see that it touches here and here. So that's more than once. So this would not have an inverse. This one is tricky. So when you draw a horizontal line, if you draw it here, you might say that crosses more than once. It touches it in multiple areas. Well, this is actually known as an asymptote right here, and it's going to get closer and closer and closer to the x-axis without ever touching. So this also will have an inverse, even though it looks like it doesn't.